Thank you. Okay, everyone listen. So these three things are kind of broad. At the same time, we are going to kind of try to summarize them. The idea of unit circle. Now, if you look at this, right? I need your attention here. Drop. I know you can hear me, but I need you to always look at the board, okay? Now, the unit circle, let's just see how the topic sounds. What comes to your mind? All these questions I'm asking, I do not want the HL students to respond because you have done the unit circle over Zoom. What comes to your mind when you hear those three words, the unit circle? Just give me an idea. Because I like to link a topic to the meaning, the message is passing across. Because once that is taken care of, it's easier to understand. Okay? Anyone, I don't need a perfect answer. You can tell me something that doesn't even make sense. It's fine. Just try. The unit circle. Yes, ma'am? Something to do with pi. Something to do with? Pi. Now, everything has to do with pi. Everything in trigonometry has to do with pi. But nice try. Anyone else? Say that again?
Sine, cosine, tangent.
We're in trigonometry, obviously. Give me something relating to the unit circle. Don't give me something like, oh, we learned that in Form 5. Of course we know. This is Form 5. Don't give me answers like that. The unit circle. Those three words. What comes to your mind when you hear those three words, the unit circle? Come on. Yes, another try.
Segments and circumferences?
Do you know what a segment is?
Yes.
What is a segment?
It's with lines.
A segment is not a line.
Like,
Is a segment a circle, guys?
no.
So why is segment coming into a circle? It's like me saying, tell me about that Chinese lady. And the first thing you're going to tell me is the African guy. Do you understand? The unit circle. That tells you I'm talking about a circle. So if it's not a circle, then it's not what we are looking for. Try again. It might be what someone is thinking about. I don't know why you don't like to respond. You're not developing your critical thinking skill if you continue to behave like that. That's the reason I like to probe you in the class. Because you have to develop that skill of being able to think independently too. But we don't expect you to be able to do that immediately. Over the time, when you participate in this question and answer, you are developing that skill. And over time, you become better at critical thinking. Not just sit down and wait for the response. You're not going to help yourself like that. Yes, anyone, please. Or maybe I start calling people by name. Or you? Want to try?
Maybe the circle used as a unit to characterize something.
As a unit. That unit in this case is not like centimeter unit, kilometer unit, something like that. So you're close actually, but if you understand what that unit means, then you'll be perfect. Kelly, I give you food if you get it. Okay, I'm not giving you food. I'm not going to risk my food. Denise?
I think it's actually similar to Polio's. Yeah, it's about unit, but I'm not sure.
How about you? Neighbor? Neighbor 1? Then I go to neighbor 2. Say that again?
I'm not reminded of anything.
Okay. How about you, neighbor 2?
You see something about radian.
Say that again?
Radian.
Don't think radian, don't think degree at all. Say that again.
I mean, you're using it like this circumference of a circle as like a ratio.
Okay, I'll try to the HL now. And then tell me you forgot already.
If I get it, can I get food? Because I think food will.
Some nuts are there, so you can have that as much
Not
as you
there.
want.
Oh, okay, a unit.
Okay, it's transferred.
A
Yeah.
unit circle is a circle with the radius of 1 unit.
That's it. A circle with radius 1 unit. That's it. You see, some of the problem that we have as learners is that we think too much. If I say the red circle, the green circle, the brown circle, the white circle, the big circle, the small circle, this is just trying to describe the circle. It has nothing to do with whether it is drawn by a Nigerian or a Chinese. It has nothing to do with radian or degree. I'm only describing the circle. Okay? Just like I could put the word red. So when you look, oh, that means the circle that was drawn in red ink. It's as simple as that. You're thinking too much. That's the problem. Because you thought what I'm looking for has to do with some Cambridge PhD answer. No, I'm asking you something physics. But you thought, oh, that couldn't have been what he's asking. This is from 5. No. Do you understand? I think that was the issue. The unit circle, the word unit, okay, mathematically represent 1. You remember 100 tens and unit? Right, remember that? Another word for unit is what?
1.
Ones. When you do place value in middle school, right? Some will say 100 tens and unit. Some will say 100 tens and ones. So unit has to do with 1. So when we say the unit circle, we're talking about a circle with radius 1 unit. So if I'm drawing on a piece of paper, maybe I meant 1 centimeter. If I'm drawing it on the street of Macau, maybe I meant 1 meter or 1 kilometer, as long as it's 1 unit. Do you understand my point now? The unit circle simply means a circle with radius 1 unit. So we're going to use the idea of the unit circle and link into trigonometry. Then I'm going to show you some things whereby when we get to solving equation, it is easy for you to pick your result just from the unit circle. Okay, so let's begin. Maybe I start with the definition of the unit circle, which we have just talked about now. Then we link into sine and cosine rule. May I manage this space if you don't mind? Okay, just put this here maybe. Okay, thanks. All right, this right. Just as I'm writing, I'll be explaining. Then I'll pause you so that we don't waste too much time. Okay, so please write the unit circle. So this is a circle on the xy plane. This radius must be of length 1. Then you have a unit circle. That's what the unit circle means. So because it's of radius 1, then we know the intersection. So it means on the x-axis, we can have the following. What will be the point here on the x-axis? 1. What about here? What? What about here? And what about this one?
1.
Because the radius is 1, right? So all those distances are 1, 1, 1. Question. If I connect all these points of intersection together, what shape do I get? Square. A square. Are you sure it's a square? Why can't it be a rhombus?
Because
If a rhombus too, lengths are the same.
And also 90 degrees.
Yeah, the rhombus too also has 90 degrees. If this is a rhombus, this is 92. All these lengths are also the same. Or is a rhombus the same as a square?
Oh, because square is a special case of a rhombus.
So the angle is 90 degrees.
That's what we're saying. Oh, you mean angle here?
Yeah.
Okay. What else can I say to kick them off?
Oh,
Okay, yeah, the angle will be
when
different.
you connect that,
Then, say that
when
again.
you connect when you connect the,
Diagonal, yes.
yeah,
There is-
it's different.
How do you mean?
The diagonal like this. Yes.
Yeah, this one, yeah.
I could just move this like this. I could just rotate this here to look like this.
No, what I mean is the length of these two diagonals.
The length of the diagonal. Say what you meant. Don't make me assume what you meant, because I'm just going to pretend I don't know what you're saying, even though I know what you're saying. Okay? The length of the diagonals are different. And as a result of that, the angle here is not 90 degrees. Okay? That's the difference between them. But here, you can see clearly the length of the diagonals will be the same. 2, right? So, and if these spaces should be the same. So, if you connect, you get a square, not a rhombus. Anyway, it has nothing to do with what we are doing. I don't know why my brain thought of that. My brain sometimes can be confused too. Maybe not. Now, we're going to link these two angles. Let's say, we're going to call this point maybe a point P. Okay? I'm going to summarize what I have in the book. I'm not going to go into details the way it is done in the book. There's something called equation of a circle, which you don't need to worry about. Suppose P, A, comma B, I don't want to call it X, comma Y, because the entire space here is X and the entire axis is Y. So suppose P, A, comma B is any point on the circle. So that is going to look like this. But at any point on the circle, center is O. Center 0, 0, because it's very important. If the center is not 0, 0, then we don't have what we are talking about. So I have my XY axis. This is my Y axis, this is my X axis. What we are saying is that P is somewhere here. And P, the coordinate of P is A, comma B. You agree with me, if the coordinate of P is A, comma B, that I can trace it to both X and Y axes. Is that not? Please look at this now.
Oh.
What will be this?
Right angle.
Say that again?
Right.
What?
A.
A. I'm tracing something down.
Yeah.
This will be A, right? It means on the x-axis, the value here is A.
Yeah.
And since this is the origin, it means the base of this triangle is of length A. Because I'm starting from 0. That's the reason I added this.
Yeah.
Understand?
Yeah.
So this is A. Similarly, Ryan, is that your food? Are you ordering food in the class? No. Just kidding. Similarly, the length here is B. So we can say the height of this triangle is B. And of course, right angle like somebody said. Okay? So we have a right angle triangle. What is the hypotenuse of this right angle triangle?
Square root of A squared plus B squared.
No.
Hypotenuse.
Oh,
A
1.
squared plus B squared equals C squared.
No, you're thinking too much again. I'm asking you P6. You are telling me master's degree?
1.
What is the hypotenuse of this triangle? 1. We're dealing with a unit circle. The radius is the hypotenuse. Okay? So this is 1. Okay? Now, suppose this P is a point such that, you see, this is why you don't do too much OCD. Such that OP moves through an angle theta from the origin. From your IGCSE level, you know we go in this direction, right? Hello? This is your clockwise direction, is it? Which one is clockwise again? This is clockwise.
Yeah.
We go anti-clockwise. So these are quadrant 1, quadrant 2, quadrant 3, quadrant 4.
Yes.
We go in that direction. I hope you remember that from previous grade. Now, if P moves through an angle theta from the origin, so this is our origin, that's my point. Hello?
Yes.
This is 0, 0, this is 90, 180, 270, then go back to 360.
Yes.
I hope you remember that. So I don't need to demonstrate that here, do I?
No.
Okay, great. So if P moves through an angle of theta, then this is theta. That's what I'm trying to say. Hello? Then we can bring out a right angle triangle with angle theta. I don't need to bring that out. If this is my theta, is this, which one is opposite, hypotenuse, or adjacent? Hypotenuse is what?
1.
Opposite is?
B.
And adjacent is?
A.
Perfect. So we can write our sine, cos, and tan. Let's see. Sine theta is equal to b over 1. Agree?
Yeah.
So basically, b is equal to sine theta. Are you with me? We just focus on sine and cos for now. Cos theta is equal to what? A over 1, which implies that a is equal to cos theta. Are you following, please?
Yes.
Sine is opposite hypotenuse. I didn't write O over H. I'm just saving time.
Yes.
These two means that we can now redraw our unit circle in terms of sine and cos. Basically, P cos theta, comma sine theta. That's what I'm trying to tell you.
Yes.
Okay? That is the link between our unit circle and the trig that I'm trying to communicate to us. Look, we are going to take it one by one now. Now, before we move further, we can apply the Pythagoras Theorem, and this becomes the first identity that you are going to learn. I was supposed to discuss this later, but we can as well just add it to it now. We can find tan theta as well. Tan theta is what?
B over
B over
A.
A. And your B is what?
Sine theta.
Divided by?
Cos theta.
So this is actually one of the trig identities to be learned later. So this implies that the tan of an angle is actually the sine of the same angle divided by the cos of the same angle. This is one of the trig identities that you will learn. Okay? By Pythagoras Theorem, can somebody tell me Pythagoras Theorem applying it on this triangle?
A squared plus B squared
A squared plus B squared
equals to 1.
equals to 1. But what is our A?
Cos.
A is not sine. Okay? Cos theta. So this is cos theta squared
Plus
sine
sine theta.
theta squared is equal to.
1.
So this is an identity to be learned also by the old class, of course. So we write it as cos squared. We don't say cos theta squared. You put the square on cos. But it simply means you find the cos of the angle, then you square everything.
Oh, okay.
It's not square the angle before you find the cosine. Do you understand that? But this is how we write it. But this is what it means. Plus sine squared theta is equal to 1. So these two are part of the identities to be learned and to be applied. But they can be easily seen from here now. So we might as well just put them down. We call this the Pythagorean identity. So if you have seen your syllabus and it says you have to learn Pythagorean identity, this is it. Of course, there are consequences of this Pythagorean identity. The consequences are, if I want to make cos squared the subject, what will it be? Cos squared theta equals to what? 1 minus.
Sine squared.
And if I want to make sine squared the subject, what will it be? So we are going to be doing some work later, and you are going to need to either use this when you come across 1, or when you come across cos squared, you write it as this, and so on. Okay? Now, a question was given this year. It's about trig. Maybe we solve it under trig equation later. You are going to need this for trig equation. That is the last thing I want to discuss next week. Understand? But we're going to need this a lot. So, from the unit circle, we can see this already. So let's take note of that. With this latest information, I'm going to now draw my unit circle in a different way. Please write quickly. maybe I think the next thing I should link it to, if I'm going to follow your book, is the periodicity of the units of the trig ratio. So from previous section, we have the following. Please, let's try to focus and understand what we are doing. It's not a difficult concept, trust me. We just need to be focused. Miss Joey, is everything captured?
Captured?
Okay, thanks. So far, you said if the angle through which it moves is theta, then the coordinates P, instead of A comma B, it will be cos theta comma sine theta. Understand? This is the x-axis, this is the y-axis. So that is a summary from what we have done. I have a question. Everybody listen. I have a question. You see, the coordinate of P, you know the coordinate is always x comma y. Right? So when x is cos theta, y is sine theta at this point. And P will move around anyway. Okay, so depending on what the angle will be, it will still continue the same way. But it's possible that maybe it's positive somewhere or it's negative somewhere. Alright? Now, you also agree with me that this value is between 0 and 1. Right?
Yes.
If P was at the origin, which of them is 0, which of them is 1? If P was here. Cos is what?
Sine will be 0. Sine theta will be 0.
Sine theta will be 0, are you sure?
Yes.
Yeah.
You're sure? Because here, x is a value, not 0. Right?
Yes.
But y is 0. Right?
Yeah.
What value is this one?
1.
1. So my x is 1 here, which means my cos is 1.
Yes.
But my y is 0. Hello? Is there anyone who doesn't understand this? Because that's actually one of the activities you are going to do. This is x comma y.
Yes.
Right? X is this one, y is this one. Y is on this line, x is on this line. So at this point, please, if you want to go out, please go out. But I don't need this playful whatever. All right? Thank you. At this point, x is a value that is not 0.
Yes.
But y is here. If you trace it to y-axis, y is here at the origin. So y is 0. So which means if we are here, my y, which is sine, will be 0. My x, which is cos, will be 1. Does that make sense?
Yes.
When you get here, which of them is 0, which of them is 1?
Cos theta is 0. Cos theta is 0.
Cos theta is 0.
Yes.
Because cos theta is the x-axis. So on the x-axis, on this line, x is equal to 0. Isn't that what we call the y-intercept anyway?
Yes.
Y-intercept is when x is equal to 0, right?
Yes.
So x is 0, but y is 1, which is the maximum you can get. But in between, what can you say about the cos and the sine? They are what?
1.
Speak louder, please.
They're not 0.
I know. So what can you say about them?
They're between 0 and 1.
They are between
0 and 1.
they are between 0 and 1.
Yeah.
Like 0 point something, not up to 1. Because when this moves, it's going to be somewhere here, right? And the y is going to be somewhere here. So it's between 0 and 1, both the cos and the sine. Similarly, when you come here, this is minus 1. This is 1. So it's also going to be between minus 1 and 1. In any way, cos and sine will always be between minus 1 and 1 as it moves around this. Okay? That is something that I should have had somewhere. But it's a known fact. Everybody knows that from IGCSE. Hello? Now, what do I want to ask you now? If you go, what happens? Now, this is my initial point of P. Okay? From that point, I decided to rotate it 360 degree or 2 pi. I can use 360 degree or 2 pi interchangeably. So I need you to get used to both. Maybe Anika, from here, she decided to just spin this one revolution. You know what one revolution means? One circular rotation like that, 360. What can you say about the new position of P? Still the same? Are you sure?
Yes.
Okay, the next question goes to Ada. Anika did one spin. Everybody says is going to come back here. Okay? Now, Joe is trying to do too much. She decided to do 3 complete revolutions. What can you say about the new position of P?
It would still be the same.
Are you sure about that? Think very well. You think so? Of course she's right. I'm just being me. The confucianist of the class.
Yeah.
Do you understand? It's still going to be the same. And this is so what we call the periodicity of sine and cosine. Take out your calculator, everybody. Quickly. You can be in degree or radian. If you're in radian, you think of pi. If you're in degree, you don't need to worry about pi. Are we in degree or radian? Degree. Now, press sine. Pick any number of your choice. Is equal to. The answer is going to be on your screen. Yes?
Yes.
Now, press sine again. Open bracket. That same value, don't press is equal to, please. That same value, okay, plus, do you want to take over or just shush your mouth? If you're not interested, you may leave my class. That same value, are you there yet?
Yes.
Plus, one revolution is how many degrees?
360.
Now, I don't want you to say 360. I want you to say 360 times any number that comes to your mind. Then it's equal to. Compare with the first result. It will always be the same. That is what you have just confirmed by telling me if Anika decides to spin from any position. So the initial peak could be here. But you decide to spin it one revolution, you're going to have to come back to the same point. Okay? Can you try the same thing with cosine? Press cosine of any value. Check the answer. Of course, any value doesn't mean from 0 to 90 alone. You can decide to press cosine of 200, your choice. But make sure the value is within 0 and 360. Then press cosine of that same value plus 360 times any integer that comes to your mind. In fact, you may try negative integer too. Negative integer means what in this case?
Just the
other way around. So you may decide to spin it clockwise or you spin it anti-clockwise. Okay, no, this is clockwise. It doesn't matter. What did you notice there? Same thing. So we say that sine and cosine are periodic functions. And the period is 2 pi. Periodic function means it is exactly the same at a particular interval. Hello? Have you seen a sine graph before?
Yes.
I believe yes. You have seen that from your IGCSE classes. But this is what the sine graph looks like. Miss Joey, are we here? Sorry,
we'll be back.
we're asking so much. This is what a sine graph looks like this. You probably have done a few in physics. The sine graph is exactly the same after every 360 degree or 2 pi. This is your 0. This is going to be your 180. This is your 2 pi. You see, from here to here, it's just being replicated. So you cut this, you move it here, that's what it looks like. Or you come backward. Maybe I don't want to start from 0. You may decide to start from here. But this is 90. This is 180. You mean one more 90. Is that enough? So you can also cut from here, and you realize it's going to be the same thing. So we say sine is a periodic function with period 2 pi. It means the sine is exactly the same after every 2 pi. Or after every 360 degrees. The same with cosine. And that is what the periodicity is all about. Let's write quickly. Let's write something on that. if OP is